Okay, this is Mr. Great Tech Review. You are welcome to today's tutorial at Mr. Great Tech Review Studio. And today we are going to discuss about binary numbers and the decimal numbers and all about switch making a binary counter. In today's tutorial, we are going to make a binary counter. You see, Arduino, just like I said before in my tutorial when I was introducing this most excellent starter kit, Uno starter kit, I used Arduino Uno in the kit. I told you before. Let me open it and bring out the Arduino Uno board. And okay, so this little board is nothing but a switch. Just like I said, it's nothing but a switch. Let me put it in this my camera so this camera will pick it up. Like I said, this little board is nothing but a switch. It's nothing but a switch. Just like I mentioned before, I said this little board is nothing but a switch. It has a microchip, Atmel microchip inside, which contains billions and millions of switches inside of them, and it understands only two numbers, which is zeros and one, and that is digital electronics for you. So these thousands of switches comes on, turns off, on and off, low, high, at a very high speed. So when in computer you have, say, the processor speed of a computer. In computer you have Intel processor and the other processors, maybe, and there are other companies manufacturing processors for PC and Mac also. So but Intel is the most popular one, and at a very high speed. So I have a speed of a processor 2 gigahertz processor. What does that mean? It means 3 gigahertz, 2 gigahertz, 3000 gigahertz per second. That is per second. That is the speed at which it turns on and off the switches inside the processor. That is the speed, gigahertz per second, for 1 second. So that is just the switch, the speed of a switch. So it tells you the whole makeup of a computer, a processor, or a microcontroller is all about switches jam-packed together, and it turns on and turns off at a very high speed rate, at a very fast speed. Okay, now on today's topic, we are going to see how this chip receives this information. It's not about putting in codes and using codes to to tell the computer what to do. I just want you to understand what is actually going on inside this, how this processor, how this microcontroller understands whatever you are putting inside. All of this music, alphabets, they can be represented in numbers, whatever thing you are seeing, pictures, music you're hearing, and they can be represented with zeros and one. It's only zeros and one that this guy understands. So whatever code you are putting in, this guy interprets it as zeros and one. So alphabets, everything, pictures, you can represent them with zeros and one. So it takes us down to our secondary schools, high school, binary numbers and decimal numbers, and numbering system. You have to understand how it works. So the base 10 and the rest of that, and you have to understand how this binary number works, and that is it. So now, and I have so that to make this tutorial very fast, I just drafted something, and I don't need to be drafting it in this tutorial, so that we make it a little bit shorter, so that we don't have a cumbersome tutorial, and it will be also to stay longer time watching this tutorial. So I just wanted to make it as short as possible. So that's why I've created out time to put these numbers down here. And okay, now the number system, you have your zero. You start with your zero. Zero is very important. You don't start with one, you start with zero. So you have your zero, you have your 1 2 3 4 5 6 7 8, sorry, and you get to 9. So you get to 9, and the 9 plus 1 is 0. You put down 1. So you add 1 to 0. 0 plus 1 is what? Is 10 plus 1 is what? A 1, you kind and bring down 1. So no, this is how it goes. So let me just put it in such a way that I too will understand what I'm saying. Okay, so where am I now? Okay, let me bring the camera close. Okay, so I have forget about this one. Let me close this for now. It will not confuse you. Let me close this for now. Okay, so we have 0 to 9, and the 9 plus 1 is 0. You bring down 1. So you add 1 to 10, you have 11. Add 1 to 10, you have what? 11. 0 plus 1 is 1, you bring down 1. Then you add 11, you add 1 to this place, you have 2. You bring down 1. You add 1 to 2, you have 3. You bring down 1. So that is it till 15. So that is the numbering system, the decimal system. And this decimal system, you have the first here, you have on 1 unit, you have the 10 units. So this is the 1 unit, you have 10 units. So when it comes to binary system, mind you, we want to achieve a 4-digit binary counter, a binary counter, 4-bit binary counter. So that is what we are going to use Arduino to achieve. Okay, now let's see how we got all these codes here, all these binary codes here, all these binary 000, 001, 000 stuff and rest of them. Okay, now we start with 00. We have 000, you have 4 zeros. Then we add 1 to 0. You have 1, you have 3 zeros. 1, 2, 3, you add zeros. So you add 1 plus 1 here. You add 1 to here plus 1 here. Then you have what? You have what? Not 2. You have what? You have 0. You carry 1. You bring down the 1. You write 0, 0, 0. Then you add another 1. 1 to 0. You put 1. You put 1 plus. You add another. You bring down 1. And you have 0, 0. Then you add what? Again to this. To this you add what? So let's do it in such a way that you are going to understand what I'm doing. Okay, let me use this paper so that we can be able to. So you have this, you add this is 0, 1, 0, 0. You add 1. So 1 plus 0 is what? 1, 0, what? 1, 0. So that is 0, 1, 0, 1. So that is it. That is 5 for you. It was to 5. Then you want to get this one 6, so you have to do it this way, the same way. So now you have to get 6. So you have to, this is, you have 1, you have 0, 1, 0, 1, you plus 1, you add 1. Then what you have here is what? You have 1 plus 1 is 0. Carry 1 here. You have 1. You have 0. So you have 0, 1, 1 as 6. So you have 0, 1, 1 as 6. So the same thing goes to 7. How we got this 7 on 6 here? We add another 1 on 6. You have another 1 on 6. So you have this. So okay. So on 6 here, you have another 1 on 6. You have 0, 6 is equals to 0, 1, 1, 0, plus 1, you add 1, then you have what? You have 0 plus 1 is what? You have 1, you have 1, you have 1, you have 0. Okay, so that is how we got this. And here is a little bit complicating on 8. So on 8 we have, on 8 you have 7, have 7 is equals to 0, 1, 1, 1. So we add 1 to this. So we have 1 plus 1 is what? It's not 2. It is what? It is 0. 1 plus 1 is 0. You carry 1. 1 plus 1 is 0. You carry 1. 1 plus 1 is 0. You have what? Sorry, 1 plus 1. You add 1 to it. You have 1. This is 7. You have you have 7, you have 0 1 1 1 at 7, you add 1 to each. 1 plus 1 is 0, carry 1. 1 plus 1 is also 0, carry 1. 1 plus 1 is 0, you carry 1, you put 1. So in 8 you have 1 0 0 0. So that is it, and follows suit to other numbers. So that is how we got, and we get to this 1 1 1. So let's do 14 and see. This is 14. So this is 14. This is how we got to 14. Let me do it so that we understand how we got these numbers. So this is how we got to 14. So we have 14. You have 14 is equals to 1 1 1 0. Then we add 1 1. So that is it. You do it the same way. 0 plus 1. You have 1. Then you have 1, you have 1, you have 1. So you have, this is 15. So 14 plus 1, that's 15. So this is 15. 15 in base, in binary is what? Is 1 1 1 is forward. So that is it. So that is how Arduino understand this program. So we are going to translate it to the practical aspect of it now. So this when you look down the line here, when you look down the line, you will see there is a pattern at which this thing goes. There is a pattern at which this thing goes. So there's a pattern in these numbers here. There's pattern. The first one, you have 1 0 1 1 0 1 1 0 1 1 0 1. So this goes in a pattern of 1. What 1? So that is it. So 1 times the number is how this one goes. So you have 1 here because it goes in the pattern of 1. So in this place, it goes in the pattern of 2 zeros 1 1 2 1, 2 zeros 2 1. So it what 2? So 2 here, and the same thing goes here. You have 4 zeros, so you have 4. And have 8 0. You have 8 zeros, and you have 8 1. So this is how it goes. So now this is how we are going to do it. It's very simple. It's very simple. And this is how we are going to do it. It's a very simple distance. So 1 times the number, what's here, it gives you what? The decimal point. So if you want to go back to, if you want to go back to the decimal, point, let me remove myself so that let me make myself a little bit, okay, let me put myself in this place. Okay, so now if you want to go back to the decimal point, to the decimal numbers, is very simple. How to go back to decimal numbers, just like I told you. And you have 0 as what? As your 0. If you are going back, I'm using blue pen, let me use green pen. You have 0 as your 0. Then you have 1 as what? 1 times 1 is what? 1, and plus 0 0 0 is still what? Is still 1. So you have this, and what you have here is 1 times 0 is what? 1 times 0 here. This is 0 here too. This is 0 here. 1 times 0 is what? Is anything times 0 is 0. 1 times 2 is what? Is 2. So here you have 2. So the same thing goes to 3. 1 times 1 is 1, and 1 times 2 is 2 plus 1. You have what? 3. So this is how we got 3. And this place, so follow suit, goes down the aisle to the last number here, which is 15. Okay, I told you we are not going to go to 16 to 30 where we have 5 digits. We have 5 digits of zeros, but we are going to do only 4-bit binary counter. This is where we are going. We are going to achieve 4-bit binary counter. Okay, now we are going to translate it to Arduino. We're moving. You see where we are going from? We are going from this place. We are going from this place. We got to binary. From binary, now we got to Arduino board. Now in Arduino board, we are going to make use of pin. We're going to make use of how many pins? We're going to make use of 4 pins for us to achieve this 4-bit binary counter. So we're going to make use of 4 pins. 4 pins from pin 2 to 5. Okay, pin 2 to 5. Let's see, pin 2 to 5. This is pin 2 to 5. Okay, and let me put it this way and come very close. Okay, sorry. Okay, so we are going to from pin 2 to 5 to pin 5. So we have 0 and 1. They are used for other things. You can still use pin 1, but you can see it's TX, RX. They are used for transfer of information. So we better leave. This is what Arduino use. This pin Arduino use it for other things. So we are going to exclude this pin 1. So let's use, I will still come to that with the function of this, the extra function of this pin 1, that why we don't normally use it. So so let's come to pin. We use pin 2, 3, 4 and 5 to achieve that. So just like I said, you use 4 LEDs to achieve this 4-bit binary counter. Use 4 LEDs. So now we are going to see how 1 will be represented and how zeros will be represented using LEDs, using Arduino, and see how it goes off and on. So now we have 0, just like we have here with me here, and you have a 0. You have 0. So just like you have 0 here, you have 0 here, and the 0 is what? You have 4 zeros. So in this place, so let's see, we have 4 LEDs, and let's see how it goes. And we have from pin. So now let's do it this way to Arduino board. So okay, so let me add this. Let me still use my green pen. Here is my green pen. Okay, so now let me use, so let's see how it goes. Okay, 1 2 3 4. Correct. So here we have pin 1. So we have pin 1, pin 2, pin 3, pin 2, sorry, pin 2, pin 3, pin 4, and pin 5. So this is the 4 pins we are going to make use of in our Arduino. Then we have these pins, we connect them to LED, light emitting diodes. So we make use of 4 light emitting diodes. So now we make use of 4 light emitting diodes. So let's first have the first one. This is the first, second, third, and the 4th light emitting diode. So that is it. Now we are representing it with 0, mean the first one, second one, the first one. So now on the first one, which is have 0, you see that 0 is empty. So in 1 we have 1. You have 1. So the first one you have 1. So now we represent all of them, and this is light emitting diode. So we go like this. We use these zeros to represent light emitting diode. So now let's see, 1 2 3 4. So all of them have to go like this, the same way. 1 2 3 4. Okay, 1 2 3 4. Okay, 1 2 3 4. Okay, I'm coming to you understand what I'm saying. 1 2 3 4. Okay, so follow suit. 1 2 3 4. 1 2 3 4. 1 2 3 4. 1 2 3 4. 1 2 3 4. 1 2 3 4. 1 2 3 4. 1 2 3 4. Okay, 1 2 3 4, and the last one, 1 2 3 4, and that is the last one. 1 2 3 4. So that is the last one. Now so now we are going to represent the LED with dots. So on the first one, we have the first 0. We have the 0 here, which is on offset, just like those zeros and 1. You understand, the microchip understands zeros and 1 information. That is only what you understand. So off and on, low and high. So that is what you understand. So now I'm going to shade now. So let's shade the first one. The first one, you have nothing to shade there. The first one, you have nothing to shade here. So you don't have anything. So it's off. It's on off state. So I'm going to use black to do the off state. So it's on the off state, so it's bam 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 bam, so it's 0, it's nothing is there. So on the second, the first one, you have 1, so 1 is on, you have 1 on here. So for your first LED, which is your LED number 5, is going to, starting from here, is going to be what? Is going to be on. Okay, so but let's do it the normal way. Let's do it the normal way we see it here, and I think that should be better. That should be better. Doing it that way would be better. So here we have, and let's do it that way. I think it should be better that way. Here we have 0 0 0 0, and here we have 0 0 0 1. I have 1, and here we have 0 0 1. You have 0. So here we have a 0 0, you have 1 1. So we have 0, you have 1, you have, and then you have 0 0. So you have 0 1 0 1. You have, okay, here we have 0 1 0 1. So in this one we have 0 0. So let's see. I think this should be better. This should be better than this, and this should be better than this. Okay, now, okay, you have this one. You have a this thing is tiring, but we have to do it. Okay, so this one we have a 6. We have 0. We have 1 1. We have 0 0. So you have 0, you have 1 1 1. So you have 1 8. You have 1. You have then 3 zeros. That's straight off. So you have on high here. Okay, so 9 we have high, which is LED on high. Then you have low, then you have high again. Okay, let's use the word low and high. So on 10 we have what? High 1, which is high. So high, you have low, you have high, you have low again, you have low again. On 11 we have high, we have low, we have high. On 12 we have high, we have low, off. Then we have on, which is 13, on, off, what? On. 14 we have on, we have off. On the last one, 15, you have on, before LED turns on. So okay, this is better. I think this is wrong, and this is better. So do this one, do it this way. Okay, so let's follow the numbers the way it is on the binary, and let's arrange the LED like that. So on the LED now you have your first LED number 1, number 2, number 3, number 4. Yeah, that is the fourth LED. Then you have your pin. You have your pin number, pin 2, pin 3, pin 4, and pin 5. So this is your Arduino pin, your Arduino pin. So this is your Arduino pin. So pin numbers on your Arduino. So if you are using pin number 2, pin number 3, pin number 4, pin number 5, and this is your LED. You have to use the LED number 1, 2, 3, 4. So you use 4 LEDs to represent these 4 binary codes, zeros and one. So use for LED. Remember, the first one, the LED turns off, which is 0. So we have 0, 0, 0, 0. So here the LED is off. It's not on, so the four of them mean off is meaning 0. And then the last one here, the LED, all of them turns on, that is 15. It represents 15. So this is how Arduino sees this program. This is how Arduino sees this program. So it's very easy for you to understand. So this is it. So this little thing we did here, we are going to translate it into programs. We are going to write a program for it. So this is just the rough sketch for you to understand, actually, for you to understand what these things are all about, and for you to come to understanding of what these things is all about. I think it's better this way. Okay, so let's go to the practical and write the code and do the 4-bit binary counter. Let's do the hardware, and then we'll do the software in the Arduino board. Okay, so now let's see how we can use how we can achieve that on our using our Arduino board, using the Uno board. Let's see how we can achieve that. And with 4 LEDs I have with me here, I have 4 LEDs, 4 resistors, 4 LEDs. Okay, I have 4 probes. 1, 2, 3, 4. I have 4 probes here, and let me so that okay, good. Okay, better. Okay, now so I have 4 LEDs and 4 probes for the 4 LEDs, 4 jumper probes, and that is it. Then I have 4 LEDs. 4 LEDs, and then they have 4 resistors. Just like I told you, you can use 470 ohms, 1 kilo ohms, can still work. I have 4 resistors. Then I have 4 ground cables, jumpers, 2, 3, 4. Okay, I have 5. Okay, so that is it. And I have my breadboard with me here, so on the Arduino. So let's hook it up and see and write our program inside the IDE. Okay, so now let's hook it up and see. Okay, yeah, so let's go like this. Like I told you, you have learned how you can use your breadboard, how the breadboard works. So I'm going to insert my pins here. So I have the long leg. The longer leg is my positive. The longer leg is my positive. So that is where I'll hook up my resistor. So now it goes like this. So let me start from here. So now I have this in the middle. I have my longer leg on my left hand side. So okay, let me come there so that you see what I'm doing. My longer leg on my left hand side. Okay, so here it goes. So okay, my longer leg on my left hand side. Okay, so let me come to this second column. Longer leg on my left hand side, all the longer legs on my left hand side. I give one gap, and I give one gap in between the legs, one dot in between the legs, then 2 dots, spacing for the resistors, for the LED, 1 dot in between the legs, 2 dot spacing for the LEDs. Okay, so that is it. Okay, so then we'll hook up our resistors. We have our resistors. Okay, so now here it is. So now on this side we have my positive probe. Okay, my positive probe for the pins. Okay, one is longer, one is shorter. Don't things need use short ones. I think I have a, so this one is the ground. On this side I have the ground, the legs. I have to ground the legs. So now what I will do is to ground it. I have to just ground it on here. Very simple. Ground the legs to this side. Ground the legs to this side. Ground the legs and ground the legs. And I have one common ground from here. I put one common ground. So very easy and very simple. So you can see how things are being wired in a very neat way. So that is it. So I've grounded all the legs of the resistor. Okay, so that is it. I can still come and remove these ones and bring the legs of the LED, but it will be too wide. It's going to be too wide, so I don't want to widen the legs of the LED. So that's why I do it this way. So that is it. So make sure that the legs of these components are not bridging. So arrange it very well. So that is it. Okay. So you can see it clearly. See how I wired it clearly. You see it. You see one common ground. You see the 4 pins. Okay, now so let's go. From our diagram here, we are using this. We are not using this. We are using this pin. So you have, this is 1, 2, 3, 4. So this is 1, 2, 3, 4. This is the first LED, second LED, third LED, and the fourth LED. So the first LED goes to what? Pin 2. It goes to the pin 2 of Arduino. So this is Arduino board. So this is my Arduino board. So the first LED, this one goes to pin 2. So locate pin 2. Locate pin 2. We insert it on pin 2. Pin 2. So that is it. So the second one goes to pin 3. The third one goes to pin 4. And the fourth one goes to pin 5. And pin 5. So that is it. So that is it. Okay. Very good. So very good. Then you have the ground pin. So you have the ground pin, and okay, let me still jump this one here so that all of them will go like this. Then I use this one. Sorry, see what I did? I jumped this one here so that I can take my ground from here again and put here so that all of them will come from one. So I have my ground pin here. Am I correct? Yes, I'm correct. I have my ground pin. So it looks something like this. So very neat. So all the wires are routed this way. So this is how it goes. All the LEDs come to the common bar ground. From this common bar ground, I loop to this common bar ground. Then from this common bar ground, I go to the Arduino ground. So that is it. Okay, so this is the current limiting resistor. Some of you may be asking, why are we using this? This is the current limiting resistor. Okay, now let's go to the coding aspect of it. Let's power our Arduino and see. And let's power our Arduino. Okay. My USB cord. Okay. 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 Good. Okay. Okay, go to file. Let me locate. Open. Mr. Great Uno. Okay, so this is okay, the last program we did. Okay, can we write another one? Can we open a new program, new file, and so that we can be able to write this? Okay, so okay, so files. Okay, let's just leave this and let's close this. Let's go to this and go to file. Let's go to new. Sorry. Okay, sorry. But examples, basic, bare minimum. Okay, write it there. So this file, we are going to edit it so that we can save it as save as. Okay, bare minimum. So let's save it as Mr. Great. Mr. Great. No, 4-bit binary counter, 4-bit Mr. Great, 4-bit. Okay, so let's save. So okay, so good, we are good to go. So I can close this. Okay, Mr. Great Uno 4-bit. Okay, good. This my guy has to come here. Okay, up here is okay for you. Okay, so we are going to hook up and see. Let's plug our Arduino. Okay, so now we plug our board. Okay, something is blinking. Something is blinking. There is a program in pin 2. So the first one is blinking. Okay, there is a program in this pin. Sorry. It's off. The ground is off already. Okay, let's put it back again. So okay, whatever program that is inside pin 2. Okay, we are going to, by the time we code, write our binary codes. By the time we write our codes, it's going to be wiped off, and our new program will be launched into the card. Okay, so let's do it. Okay, so there's a blinking program in that pin 2. Okay, there's a blinking program. Okay, this should be Morse code. Our Morse code is still here. We used pin 2. Transfer the pin 2. Our Morse code is still here. Okay, that's what displaying here. So that's our Morse code is there. Okay, so now let's go and see how we can now code and And this time around, I've taught you how to use variables. So we are going to make use of variables, and let's start. And okay, enter, so that we can go ahead and create our variables. So we use int command, just like I said, int. Okay, pin 2 is equals to 2 semicolon. Okay, pin number 2. Let's see. Okay, is equals to 2 semicolon. Okay, enter. Okay, we use pin 3 again. So pin 3 int, sorry, int pin 3 is equals to 3 semicolon, enter. Pin 4 int pin 4 is equals to 4 semicolon, enter. Int pin 5 pin 5 is equals to 5 semicolon. So that is it on our int variables, and we are going to put a delay, because we're going to put a delay for the program, so that it will not be a continuous. You're not going to actually see, so there must be a delay. So we put int, we use long D in our Morse code. Okay, today we can change and use wait time and as our delay. So put wait time, int again, int wait time. Okay, wait time is equals to, let's use 2000, which is 2 seconds. 2000. Okay, that is it. So now let's go to our pin mode. So our pin mode, our voice setup, we are going to write our pin mode, all our pin. Remember, pin mode, pin 2, which is our first pin, is equals to 2, and is what is an output pin. Pin 3, what to 3 is what is an output pin. All of them, they are output. They are going to power the LED, so they are all output pin. Okay, none of them is an input pin. They are all output pin. Okay, so now let's go and see and write them pin mode. So pin mode in brackets, remember your brackets, in brackets, pin 2, comma, outputs, capital letter, output, bracket closes, semicolon. So, and I have how many pins here? I have a 4 pins from pin 2 to pin 5. There are 4 pins, so all of them, they are what output. So I will do copy and paste. I will copy and paste all of that. So from here, my mouse is a little bit slow, I don't know why. let's see, Control C. Okay. Okay. Control V. Control V. Control V. Okay, so now we are going to, we have 4 of them. 1, 2, 3, 4. Okay, so 1, 2, so this has to be what? This has to be 3. So we just edit this, put 3, edit this, put 4, edit this, put 5. Okay, so that is it. So now, so that is it for this. Okay, so now we go to our void loop. Our void loop, this is where we use digital write. Okay, so digital write command. So now we're going to write what we want all this pin to do. All this pin we have set up in our void setup, all this pin. So what are we going to do with all of them? We are going to turn some of them on and some of them low, depending. So now the first one we have, just let's come to here and see the first one we have what. Okay, on the first program, the first binary code is 0, and we have it. So we are going to do this in 15 times. We are going to write this code 15 times. So now the first one is have what? You have a 0, 0, 0, 0, 0. That is low, 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 low. Low, 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 low. So you have low throughout. L, 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 L. So that is it. You have what? First one you have low, 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 low. Then the one, that is for 0 for you. On 1 we have what? We have low, low, low. We have high. Turns on high here. So that is it. So now this is what we are going to do now. So now we can see we write digital write. The first one, we are going to make it low, low, low. So, but for the sake of, let's test our circuit to make sure that everything is being wired correctly. So let's turn all this bulb high. So instead of writing low, 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 we are going to do high, high, high. We're going to come down to 15 here, and 15, which is 1, 1, 1, 1, 1, 1, 1, which is high, 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 high. Yeah, so here you have high, 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 high. So we are going to write 15 first, then later we do the other ones. We start the other ones. So we'll do copy and paste, and let's do it. So let's do it this way. Let's see, so that we can turn the whole LED on. We can turn the whole LED on. The whole LED is gonna turn on now. Okay, so that is it. So we are going to turn the whole LED on. Okay. The right way to hook this thing up so that you can see clearly what I'm doing. Okay, so now we have digital write, pin number 2 high, pin number 3 high, pin number 4 high, pin number 5 high. Okay, so do it this way, digital write. Okay, so digital write. Okay, digital write, capital letter right, sorry, digital write. Okay, the happy level orange has been turned on, showing that I'm correct. Okay. Okay, digital write, pin number 2, pin 2, comma, high, GH. close the bracket, semicolon. Okay, so digital right, so I'll copy and paste. Let's copy and paste. Control C, okay, Control V, Control, oh, sorry. Okay, Control V, Control V. Okay, so repeat the same here. So this should be 3. Okay. This should be 4. This should be 5. Okay, so that is it. So we are going to upload this program. We're going to upload this program. Remember your close glory. If it's not there, you have to put it, but it's on default, it's already here already. So let's do it and see how this is going to turn all the OLED on. Okay, so good. Wow, you can see it. Boom, all the whole LED has turned on. So on binary, this is 15, showing high. Okay, so this is it. Okay, okay, where is my 2? Okay, this is my 2. Okay, high. So that is it. Okay, so now let's see. This is 15. We have done everything high. Okay, so now let's go down and write the main program, all of the 15 codes. So we are going to code all of them from 0 to 15, all the 16 codes from 0 to 15. So we are going to start. We can also put if you put low, it's going to turn low for all of them. You can write low, and all of them goes low. So it goes off, and it will return back to this normal state before. So okay, now so let's leave it at that, and let's start coding the other code. So now this is for 1. So we are going to repeat this 16 times, and then we'll put delay in between, so as to do what? To differentiate what? To differentiate each counter from the other, each digit from the other, each number from the other. Differentiate 0 from 1 and 1 from 2. So we put a delay long, that is our wait time, and which is equals to what? So we write, say delay. Okay, so we'll put delay, so that we'll copy delay. Delay bracket, in bracket is wait time, time bracket closes, semicolon. So okay, so that is it. So we have added a delay, and that is it. So we are going to copy and paste these things 16 times. So the first one here, you have 0. The first one here, you have 0, number 0. So this first one, you have 0. So and 0 is gonna be what? Low. So we are going to paste them. So let's copy and paste all of that, and 16 times. We paste them 16 times, and we then correct all of that. So okay, so that is it. we correct them using our codes here. So now we'll copy and paste all of them 16 times. Okay, Ctrl C. So okay, so let's give the do gap to Ctrl V. Okay, so you have 2 here, you have 2 here. Okay, let's put enter 1 2. We have 3 here, 4 5 6 7 8 9 10 11 12 13 14 15 16. So this is the end of the program. So you have the first one, which is what? Low, 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 low. So you have low, 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 low. So that is it. So we are going to turn all of these low. So I'm going to write low, low, and I'm going to copy low. Ctrl C. I'm going to paste Ctrl V low, low. Okay, so this is number 1. So this is number 1, and this is 0. Okay, just to, that's a 0 here. Okay, so this is for 1. So on the 1 we have what? 0 0. Let's go. You have 0 0 0 0. You have what? You have 0 0 0 1. So you have a low, 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 high. So you have what? 1. You have low, 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 high. So you have low, 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 high. You have low, 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 high. So okay, so that is it. So now so this is 2. For number 2 we have what? We have on 2 we have low, low, high, low, 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 high, low. Low, low, high, low. So we have what? 2. We have what? Low, low, high, low. Low, low, high, low. So that is 2 for you. That is 2 for you. Low, low, high, low. Okay. Okay, so now on 3 we have 3. On 3 we have what? 3 we have low, low, high, high. Low, low, high, high. So L, L, high, high. So low, 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 high, high. Low, low, high, high. So come down again. This is 4. Okay. On 4 we have 4. We have 4. It means here is 4. This is number 4. This is number 4. So on 4 we have low, low, high, low, low. Okay. See how can I see make this thing come closer a bit. Okay, so let's come to 4. So you have low, high. This is high. You have low. You have low. So black, 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 black. So that is it. So that is number 4. So now we go for, we have low, 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 high, low, low. So we have low, high, low, low. So that is 4 for you. Low, high, low, low. So 5 we have, what on 5 we have, and the 5 we have low, high, low, high. Low, high, low, high. 5, this is 5. We have low, high. So we have low, high, low, high. So 5 we have low, high, low, high. And 6 we have low, high, high, low. 6 we have 6. This is 6. We have low, high, high, low. Okay, low here. Sorry. Okay. Low, high, low, high. Okay. Low, high, low, high. Sorry, 6 we have low, high, high, low. Sorry. This is high. low, high, high, low. Okay, Control V. Okay, that's why it's good for you to tabulate all of them so that you are not going to make mistake in your coding. So the way you see the way I tabulated it, and it's very easy for me so that I will not make mistake. Okay, now 7. This is 7. Remember, this goes to this, and sorry, this goes to this, this goes to this, this goes to this. So 7 we have low, high, high, high. Okay, now 7 we have, this is 7, we have one low and every other thing. That's 7. So one low, so one low, every other thing goes high. Okay, so that is 7 for you. Okay, now 8, we have one high, every other thing is low, low, low. So that is it, one high. And they have 8. We have 8, we have one high, and every other thing is low, 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 low. Okay. Okay, high, low, low, low. On 9 we have, this is 9, we have high, low, low, high. So that is it. So 9. So 9, this is 9. Okay, this is 9. We have, okay, now we have what? High, low, too low in the middle. Okay, okay. Okay, then this is 10. 10 we have what? 10 we have high, low, high, low. Sorry, low. Okay, so we have high, low, high, low, high, low, high, low, high, low. Okay. Okay, high, low, high, low, high, low, high, low. Okay. Okay, sorry. Okay, now 11. We have high, low, high, high. So one low after the first high. So 11, we have, this is 11. We have, okay, high, low, high, high. So that is 11 for you. That is 11 for you. Then 12. 12 we have, 12 we have high, high, low, low. Too high, too low. Too high, too low. Okay. Okay. 12 too high, too low. 13, remember this and this, this and this, this and this. Okay, 13 we have high, high, low, high. So 13 we have what? 13 we have high, high, we have high, high, low, high. So high, high, low, high, low here. High, high, low, high. 14 we have high, 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 3 high, 1 low. Okay, so 14 high, high, 3 high, 1 low. Okay, 3 high, 1 low. And the last but not the least, which is high, 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 which is 15, which is the last one, is high, 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 high. So that is 15 for you. So 16 in number. Okay, 15. And that is that. So this is the end of the whole cumbersome program. So we are going to check and see this is 0 program, this is 1 program. Okay, low, 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 low. Okay, that is it. I have 1 program. Okay, one. So low, 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 low. Okay, on the 1, that is 0 for you. You have low, 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 1 high. Okay, low, 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 1 high. On 2, we have 2 low. 2, we have 2 low, 1 high. 2, we have 2 low, 1 high, 1 low. 3, we have lot of issues. Okay, so 3 we have 2 low, 2 high. Okay, on 4 we have 1 low, 4 we have 1 low, 1 high, 1 low, 1 high, 2 low. Okay, 5 we have 1 low, 1 high, 1 low, 1 high. Okay, 6 we have low, high, high, low. 7 we have low, high, high, high. Okay, then 8 we have high and low, low, low. Okay, 9 we have high, low, low, high. Okay, 10 we have high, low, high, low. 11 we have high, low, high, high. Okay, 12 we have high, high, low, low. 13 we have high, high, low, high. 14 we have high, high, 14 we have, so that you see what I'm doing. 14 we have high, 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 low. The 15 we have high, 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 high. Okay, 15 we have high, 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 high. Okay, that is it. So we are now going to upload it and see. Now this is the end of the coding. So now let's upload and see it. And okay, so that is it. Okay. Okay. Okay, we are going to upload and see how it goes. Okay. Okay, let me just adjust so that it's not going to affect what I'm doing. Okay, now let's see. Let's upload it and see. Okay. Okay, now let's upload and see. Okay. Okay. Expected before digital right. Okay, something is wrong. Okay. Okay, let me see. Maybe it's because I added 14, 13, all the stuffs there. Let me just delete all of them and see. Okay. Okay, so now let me copy this again. Control C. Control C. Okay, let's see. Enter, paste, Control V. Okay, so now it should be 15, which is high, 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 high. Okay, this is high. GH. Okay, now let's delete this and see. Okay, okay, let's upload again. Okay, boom. Okay, so that is it. Okay. Okay, now our program has been downloaded and now it's now counting. So I will show you something on this. So now I don't know where it is now. So let me reset. Let me press the reset button so that we start from 0, where everything turns off, and start with 1 again and start counting again. Okay, so we press the reset button. This is the reset button here. I press it. Okay, I leave it. I start again. Okay, 1. Okay. Okay, let's go again and see. Okay. Okay, good. Okay, correct. Okay, good. Okay, we are good to go. Okay. 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 Okay, correct. Okay, correct. Okay. Okay, so let's go again. Let's reset and go and start afresh again. That's a 0 for you. Then you have 1. Okay. Okay, you have 2. Okay, 2. Okay. 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 Okay, 7, 8, 9, 10, 11, 12, 13, 14, 15. Good. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 0. Okay, so this is the end of the drill, and this is where we call it a day on this our tutorial number. That should be tutorial number on binary 4-bit digital counter, 4-bit counter. So 4-bit binary counter. So this is where we call it a day on this our tutorial. Okay, so now you can see how okay, you can see how everything is displaying. Okay, 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 you can see it's how it's displaying, it's counting, and you see how we program, we add our delay, our wait time, we use our variables instead of using a constant, and when it comes to, so if I want to edit, let's say, let me edit, I want to edit the delay timing, maybe to make it more, to wait longer so you can be able to count it. So just this wait time, I will come here and I will adjust it. Maybe I'll adjust to 5,000. So let's say 5 seconds. Okay, put 5,000. Okay, now I'll upload again. Okay, so now you can see it now. 0, still waiting. After 5 seconds, 1, 2. Okay, so you have 3, sorry, this is 3, you have 4, okay, you have 5, you have 6, you have 7, you have 8, you have 9. Okay, so this is it. It depends on how you are viewing it. So there's a little complicating issue here. I don't know how you are viewing it. It depends on how you are viewing it. So it depends on how you are viewing it. But I keep it in such a way that I think it would be suitable for you. I didn't know. Maybe I should turn it this way around. So let's turn it and see. Let's turn it and see. Let's turn the LED so that it will go the other way. Let's turn it like this and see. Okay, maybe I should turn it like this. Okay, let's see whether maybe this is better. Okay, let me reset. Let's start from 0 again to count it. So this is 0, and this is 1. Okay, this is 2, Okay, this is 3. Okay, this is 4. Okay, this is 5. Okay, this is 6. Okay, this is 7. Okay, this is 8. So this on my own side, I'm getting it right when it's like this. So whichever angle you are viewing it, so you have to check on the angle you are viewing it from. Okay, so that is it. And where we are now, we're almost to the end. Okay, we are on 12 now. I have 12, 13, 14, this one off, and 15 off. All of them 15. Okay, this is 15. This is where we are. Okay, so that is it. Okay, so this is the end of the program for today's tutorial. So we are here live and direct, bringing you live practical updates on Arduino tutorial. So on today, on our 4-bit binary counter, making use of 4 switches to achieve our program, we made use of 4 switches from the Arduino microcontroller. So this is 4 switches to achieve that. So when you want to do 5-digit binary counter, so you have to make use of what? 5 ports. You have to make use of 5 switches to achieve it. Have to make use of 5 switches to achieve that. So that is it. And in our next tutorial, we are going to do more practicals. And okay, you leave that one for me to decide what we are going to do on our next tutorial. Okay, so that is the end of it. I hope this program, I think this is a little bit longer because of I started with introducing binary this. Started introducing this to you. And after this, we have to interpret it. And this first one, we made a mistake in this place. In this place, and we corrected ourselves here. And that is it. So, that is the end of it. And at the end of the day, we have to stream it live and direct here, displaying here. You reset. Like I show you, your reset button start from 0 where every LED is turned off. Then you start with 1, it will count 1. After 5 seconds you have 1. So that is it. And after 5 seconds again you have 2. Okay, then after 5 seconds again you have 3. These 2 LED comes on showing you 3 on our program. Okay, so that is it. So that is the digit counter, the 4-bit binary counter displaying. Okay, on our next tutorial, we are going to add more values to our live practical updates. Okay, see you next time, and God bless you. I'm your one and only Mr. Great at Mr. Great Tech Review Studio, where we bring you live practical updates on tech. Not only Arduino, but every other tech you can think about. So as you come, let's explore. And once again, remember to get yourself this. It's very, very important. I know why I'm hammering on this. Getting the most complete starter kit. The most complete starter kit. So you have to get it so that you can enjoy what we are doing here. So the practical, like I said, is free of charge. I'm not charging a dime for this. I'm giving it to you free of charge. So whatever you are going to do, what you are going to do for me and for yourself is for you to get yourself that practical kit. Go to AliExpress or Amazon. It's around $45 to $50 depending on the site you are buying from. So get yourself that, and let's keep ourselves busy and let's learn coding, Arduino coding. And at the end of the day, we are going to do a lot of practical. So all these things I'm doing, I'm trying to drill you, my students, my proteges. I'm trying to drill you so that you get acquainted with the programming, get acquainted with the coding, the IDE environment, and all the terms, all the the coding mnemonics, the coding terms, and every other thing we're using in the coding. You get acquainted to it, enter your brain, enter your hands, and you know it, you understand it, and we can move ahead. and they start using it. So when it comes to using analog pins, using interfacing sensors, and adding shields, relay shields to do some other, I will see it application to apply whatever we have learned today. When we start applying it in the life, using it to solve life practical problems in engineering, electrical engineering, controlling valves, you will be able to understand where we are coming from and where we are going and where we are. Okay, where we are coming from, where we are, and where we are going. So that is it. Thank you very much, and God bless you. Remember to like and share and subscribe. So if this video if this video makes sense to you, like and share so that others will benefit. Thank you very much. God bless you. Bye for now.